In industries, there are many types of reactors, but the four main reactors are the batch reactor, CSTR, PFR, and also the packed weight reactor. In our experiment, we used the batch reactor. So, the assumption for using the batch reactor is firstly, there is no inlet and also the outlet flow. Second is the volume is constant. And thirdly, the mass is homogeneous throughout. So, the basic working principle of a batch reactor is that reactants are fed into the reactor. The reactants are left for a certain amount of time for the reaction to occur, and then after a certain amount of time, the products are collected. So, the advantages of using the batch reactors over the other type of reactors is, first of all, the rate of conversion of products is high. Secondly, it is easier to construct, and the third one, it is low cost. And the disadvantages will be that it is high labor cost per unit volume, because you need laborers to manually put in the reactants and also to remove the products at the end. And it is also, and another disadvantages is that it is not used for high scales or large scales of products. So the application in industries will be that it is used for small scale production and also for expensive products such as in pharmaceuticals industry and also the production of dye.
For now, I will talk about the theory part. So, in this batch reaction, there will be no feed or exit stream. So, the equation can be simplified as the rate of A produced is equal to rate of A accumulated. So, the rate of reaction is shown as here. Now, in this case, the A is the reaction product. So, the rate of reaction will be positive. If the A is consumed in this reaction, so the rate will be negative. So, in this experiment, we will do a saponification process, which is a process for fatty acid and sodium hydroxide react together to get our desired product. So, the chemical equation is shown as below. So, in our experiment, our aim is to determine the order of reaction and the rate constant. In general, there are three orders of reaction, which are zero order, first order, and second order of reaction. So this order of reaction can be differentiated by the rate law and integrated rate law. This can be differentiated by table shown here.
Linear graph with negative slope is produced. The gradient of graph will represent the rate constant. The unit for the rate constant for zero order of reaction is mole per liter per second. For first order of reaction, graph of lone initial concentration A versus time will be plotted. The linear graph with negative slope is produced. The gradient of graph represents the rate constant. The unit for rate constant for first order of reaction is 1/second. For second order of reaction, graph of 1/initial concentration A versus time will be plotted. Now, the linear graph with positive slope is produced. The gradient of graph represents the rate constant, which is the unit for rate constant is liter per mole per second.
For this experiment, there are two parts we need to do. First is the preparation of calibration curve for conversion and conductivity. The second part is to study the batch saponification reaction of ethyl acetate and sodium hydroxide. For conversion of 0.00, prepare 1 liter of 0.05 mole of sodium hydroxide. As for the second, third, fourth and fifth, we have to do the conversion of 0.25, 0.5, 0.75 and 1, and the table is right here. Before we start a new experiment, drain off any liquids in the reactor and make sure that the reactor and the tubing are cleaned properly. Use deionized water if necessary. Turn on the valve 11 and the water will be drained off. After preparing 1 liter of 0.05 sodium hydroxide, transfer the solution into the reactor by using filter funnel. After that, turn on the stirrer and set to 50 rpm. And start recording the conductivity at every 1 minute interval. Repeat the experiment with the other 4 conditions. Next, for the next experiment, which is the batch saponification reaction of ethyl acetate and sodium hydroxide, prepare 5 liter of ethyl acetate and 5 liter of sodium hydroxide and transfer it into the feed tank. To begin a batch reaction experiment, switch on pump 2 and start pumping 1 liter of 0.1 mole of ethyl acetate into the reactor. Afterwards, switch off pump 2. For the next step, switch on pump 1 and start pumping 1 liter of 0.1 mole of sodium hydroxide into the reactor as quickly as possible. After that, stop pump 1 and close the valve 1 simultaneously when the reaction of the volume reaches 2 liter. Switch on the stirrer and set the speed at about 200 rpm. Immediately start the timer. Before we start recording the conductivity values, insert the data for M and C into the equation that we collected during the calibration curve experiment. After that, record the conductivity values at 1 minute interval for 20 minutes. After 20 minutes, drain off the liquid and flush with deionized water. Repeat the step 1 to step 4 with different speed of 50, 100 and 150 of RPM.
So hello guys, now I will be explain about the result and also the analysis of our experiment. Based on the result we obtained, we can plot this result into 3 different graphs to determine the rate of reaction. So based on these 3 graphs, it is confirmed that the rate of reaction is the second order of reaction. Based on the theory that have been explained by my friends before, the chemical equation for the saponification process is shown as here. So the rate of reaction can be written as here.
Alright guys, let's get back to the graph of second order reaction. As we can see from the graph, different rotating speed will produce different straight line graph with different gradient. In overall, as the rotating speed increase, the gradient also increase. Since the gradient of the graph is represent the rate constant of the reaction, therefore, the higher the rotating speed, the higher the rate constant, which correspond to the faster reaction time. Based on the experiment, the set of experiment with rotating speed of 200 rpm shows highest rate constant. Therefore, the reaction take place will be faster. This is because as more vigorous molecules move inside the reactor, it will accelerate the reaction.
Since in this experiment, the initial concentration for NaOH and also the ethyl acetate are the same, which is 0.1 mole, so the rate of reaction can be simplified as negative dCA dt equal to KCA squared, which represent the second order of reaction. Therefore, the result obey the theory that the saponification process is the second order of reaction.
Good afternoon. So today I'll be explaining on errors and recommendations part. In this experiment, first error that might appear is the reading of volume of ethyl acetate required in order to prepare the 0.1 molarity of ethyl acetate solution is not accurate due to parallax error. To prevent that error, we can ensure that eye level is parallel with the mention of the ethyl acetate when reading the level of the ethyl acetate required to be mixed with the distilled water. So, for the second error, the batch reactor was not fully drained when changing the solution inside of the reactor, thus causing the residue from the previous solution in the reactor. So to prevent that error, we have to make sure that the batch reactor is completely drained of the previous solution before the next solution is added to the reactor. For the third error and recommendation part, the reading of the conductivity of the solution in the batch reactor is fluctuating with time. So in order to solve this problem, we need to repeat the experiment for several times to take the average value for the conductivity. So I hope these recommendations will help to minimize the errors in the experiment and improve the results in the future.